Good morning. Imagine a forest floor shimmering with blue-green light, an ocean glowing like a starry sky, or a fungus lighting up a rotting log like a tiny lantern. This isn't science fiction, it's bioluminescence, one of nature's most magical phenomena. Today we'll explore the fascinating world of animals and other organisms that glow in the dark. From deep-sea dragons to fireflies in your backyard, we'll uncover how and why they produce light, the incredible diversity of glowing life on Earth, and what this natural light show reveals about evolution, survival, and the hidden wonders of our planet. First, let's clarify. Bioluminescence is not the same as fluorescence or phosphorescence. It's chemically produced light generated by a living organism. The process involves a light-emitting molecule called luciferin and an enzyme called luciferase. When they react, usually in the presence of oxygen, they produce cold light with almost 100% efficiency, unlike a light bulb, which wastes energy as heat. This ability has evolved independently at least 40 to 50 times across the tree of life, in bacteria, fungi, insects, fish, squid, and even some worms. It's especially common in the ocean, where up to 90% of animals living below 700 meters are bioluminescent. On land, the most familiar bioluminescent animals are fireflies, actually beetles, not flies. Found in temperate and tropical regions worldwide, they use their glow for communication and courtship. Each firefly species has a unique flash pattern, a code of light that helps males and females recognize each other in the dark. In some species, females even mimic the flash patterns of other species to lure and eat unsuspecting males, a deadly form of deception known as aggressive mimicry. Interestingly, firefly larvae also glow, a warning to predators that they taste bad. This dual use of light for attraction and defense shows how versatile bioluminescence can be. In the ocean's twilight and midnight zones, where sunlight never reaches, bioluminescence is the primary source of light. Here, it serves critical survival functions. Counter-illumination. The Hawaiian bobtail squid hosts bioluminescent bacteria in a special light organ. It uses their glow to match the moonlight from above, erasing its shadow and hiding from predators below. A living invisibility cloak, luring prey. The anglerfish dangles a glowing lure, a modified dorsal spine, in front of its enormous mouth. Curious fish swim toward the light, straight into its jaws, startling predators. The deep-sea shrimp, Acanthophyra purpurea, ejects a cloud of glowing fluid, like an underwater smoke bomb, to confuse attackers and escape. Communication. Some species of lanternfish have species-specific light patterns along their bodies, possibly used to find mates in the vast darkness. While less common, bioluminescence also appears in surprising terrestrial and freshwater habitats. Glowworms. In New Zealand's Waitomo caves, the larvae of the fungus gnat Arachnocampa luminosa hang sticky, glowing threads from the ceiling to trap flying insects, turning the cave into a starry night sky. Bioluminescent fungi. Over 80 species of mushrooms glow in the dark, including Mycena chlorophyll in Japan and Pinellus stypticus in North America. Scientists believe the light may attract insects that help spread their spores. Millipedes. The Motixia millipede in California glows blue-green as a warning signal. It's toxic, and its light says, "Don't eat me." Even some earthworms, snails, and centipedes exhibit this eerie glow, reminding us that bioluminescence is far more widespread than we often realize. Across ecosystems, bioluminescence serves four main purposes: defense, startle, confuse, or warn predators, e.g., glowing millipedes; predation, lure or illuminate prey, e.g., anglerfish; camouflage, match ambient light to hide, e.g., squid; communication, find mates or signal to others of the same species, e.g., fireflies. The fact that this trait evolved so many times independently shows how powerfully advantageous it is in dark environments, whether deep ocean, dense forest, or underground cave. Bioluminescence isn't just beautiful, it's useful to science. The green fluorescent protein, GFP, from a jellyfish earned scientists a Nobel Prize in Chemistry, 2008, and is now used to track cancer cells, study brain activity, and monitor pollution. But many glowing species are threatened. Fireflies are declining due to light pollution, habitat loss, and pesticide use. Artificial light drowns out their signals. Cave ecosystems are fragile and vulnerable to tourism and development. Deep sea habitats face threats from mining and trawling. Protecting these creatures means protecting dark skies, clean waters, and wild places. Animals that glow in the dark remind us that life finds brilliant ways to thrive, even in the deepest darkness. Their light is not for us, yet it fills us with wonder. In a world increasingly illuminated by artificial glare, these natural lanterns offer a humbling message. True magic still exists in the quiet, hidden corners of our planet. As marine biologist Edith Widder says, bioluminescence is the language of life in the deep. If we learn to listen, it can teach us about the ocean and ourselves. Thank you.